All right, guys, let's begin. Where were we? We had just finished in our last class standard form. Today we're going to continue on forward. We're going to try and see what we can cover during the length of this class. Apologies about beginning late. I was just stuck. Hmm. Okay, let's continue. So now we know from what you may call just a moment. Now we're going to begin with what you may call rounding off an estimation, and we're going to try and see what we can, you know, use those for. Now, this is an extremely easy topic. That's why I picked it for today, because it's something that I can be done well within the hour. So now it's, you need to know what are limits of accuracy. Even though this topic's rather easier to do. And again, I will say that this is much more of a um, what you may call a paper two oriented question. It is still, extremely vital because sometimes the examiner, I don't think I have seen this pattern that he does like to, ask this question, these type of questions a lot. So, we need to know this. Most of the stuff that we're going to, go through with during the during this class is going to be already well known to you guys. So it's not going to be an issue at all. This is just, let's just say that this is some sort of a recap. This may seem extremely easy. And let's get on with it. So, first off, when we look into your what you may call mm, estimation and rounding off and all of that stuff, we look into if we look into your syllabus as well. Just below standard form, I'm opening up the extended form of your syllabus. There is estimation and rounding off and limits of accuracy and stuff of that sort. All right. So we're going to continue on with this. Now, first off, we need to know, basically your syllabus as well, that you need to know how to round off or estimate certain values. Now usually it is given in the question that you have to round it off to at least two decimal places or three decimal places. It's given to you in the question. If that is not the case, if you're getting a decimal answer, and if it's not written in the question how many decimals they want the answer in, you can just round it off to the number of decimal spaces or to the number of significant figures that are provided to you in the question. So whatever shape or form your question is written in, like for example, if your question is written in three decimal places, then if it's not specified how many decimal places you need to write your answer in, you can just write it with the same style that your question was written in, which is for example three decimal places. Now rounding off is extremely easy. We've done it before multiple times. This is like a walk in the past for us, that it is very easy, and but because it's part of the syllabus you have to do it again. So whenever I'm rounding something off, the best way to, understand this is, through, I can draw a number line. Hopefully you guys remember what a number line was. And any number which is given to you from, you can call 1 till 10, or any number in general, any single digit number from, let's just say, 0 to 10 or 10 to 20. The halfway point is always for a number with a 10 gap interval. Like any number which has a 10 gap interval with the next number, or any number which is divisible by 10 has another gap of 10 with the other number. The halfway point of that number is always divisible by 5. Like for example, 0 to 10 is going to have a halfway point of 5. 10 to 20 is going to have a halfway point of 15, right? And so on and so forth. 20 and 30 is going to have a halfway point of 25. So you can clearly see that any number, any two extreme numbers divisible by 10 have a what you may call a halfway point of 5. All right. Knowing this, what's going to happen is that whatever number you may have, like let's just take two numbers, for example, like any A or B. Obviously, because you're rounding it off, they're going to be, rounded off to the nearest multiple of 10. So you're always going to be concerned with rounding off to the nearest multiple of 10. And because of that, I already know that whatever multiple it may be, if the halfway point is going to be divisible by 5. So it's going to have some sort of, 5 in it, 25, 35, whatever it is. So whenever we're rounding off, we round it off to the nearest multiple of 10. Clear? Keeping this in mind, that shows tell me that hopefully I can get this right. Wait. I want it to be in the exact middle. I think that's it. Yep. Looks to be exact. Whatever that number may be, it is going to be 5. All right. So in the middle, it is going to have any number which is, divisible by 5. Keeping this in mind, whatever number you're about to round off, if your number lies between this region, if your number lies in this region, inclusive of 5, if there's any number which you need to round off, like for example, let's just say that x is greater than equal to 5 and it's less than equal to less than b. What you're going to do is that you're simply going to round off x to the number wherever it if x lies in this region, then you're just simply going to round off x to the next number, which is b. Now keep this in mind that x is also inclusive of 5. Like for example, 75, if it's being rounded off to the nearest 10, it's going to be rounded off to what you may call b. Clear? Also, keeping this in mind, what's going to happen next? Now, for example, if your x lies between it's greater than a, but it's less than whatever 5 you have. So it's less than the halfway point. Then you're simply going to round off x to a. Now that's just common, simple language. Like that's really easy to understand. So you just need to identify it. And now you also need to identify the nearest multiple. All right. So how do you find out the midway point of that number, whatever you're trying to round it off to? You simply do what is that you can simply put the nearest or the limit of accuracy. And if you don't know what the middle point is going to be, so you can just simply put the limit of accuracy over 2. Clear? So you can simply put the limit of accuracy over 2. What is the limit of accuracy? Whichever you're trying to round it off to. Like, for example, um, extremely easy. This is that it's going to be, let's just say that 74, or you can say round off, 74 to the nearest 100. Now, if you're rounding off 74 to the nearest 100, then obviously you already know that my limit of accuracy is what? My limit of accuracy is 100. And if I divide that by 2, it's going to be 50. So that means that if my number is whatever number which is divisible by 5, if it's greater than 50, then I'm going to round it off to the next number. So I can simply say that 74 can be rounded off to, and this wavy sort of is equal to sign shows round off. It is rounded off to 100. Now, simply, if the same question is slightly altered and written like this, 74 to the nearest 10, then matter becomes a bit more tricky because now your nearest has changed. So now you're going to have 10 over 2, which is going to be 5. So your midway point is 5. Before it was 50. 5 of what? 5 in between 70 and 80, because these are the nearest tens. Between 74, which are the nearest 10 numbers, like divisible by 10, 70 and 80. And in between that is 5. So if your number is less than 75, it's going to revert back. So the same number is now rounded off differently, just because of the fact that your limit of accuracy was different. Is this clear, guys? Any issues with this? All right. Anyone who does not get this, this is like very easy, though. All right. And same goes for decimal, guys. Again, whatever decimal you have to round it off to, you can just simply write it down. Okay, guys, write this down. Just give me a moment. All right, guys, apologies about that. Let's continue. So, one thing that you need to know is that what we're going to try and do is that whenever it is, it can be a decimal, it can be anything, whatever it may be, you just need to know that whatever number it is, it needs to be, if it's greater than 5, then it's going to be rounded off to the next number. If it's less than 5, it's going to be rounded off to the previous number. Is this clear? If there's anyone who doesn't get this, let me know. Next up, you're going to have significant figures. Now, this is all like really, really easy stuff. Now, significant figures are undoubtedly very easy once you get to know them. Usually, the examiner, I will let you know that the examiner does not deduct marks for the inappropriate amount of significant figures. But unless and until he has not mentioned in the question that you have to write it, according to these number of significant figures, then you have to adhere to it. And then if you don't do it, he's probably going to cut 1 mark, or carry one error forward and cut 1 mark from the entire question or something of that sort. All right. So for significant figures, you need to be cautious about them. If it's mentioned, if it's not mentioned, write at least three significant figures. That's fairly enough. Okay. Let's see. So what are significant figures? We already know, like, the what you may call the zeros. Let's begin with that. So the zeros before or before any number in a decimal are insignificant. That means that they are not significant. So for example, 0.0006 only has one significant figure, because the rest, the zeros at the beginning of a decimal are not, uh, before any number in a decimal are insignificant. Keeping this forward, any zero, you can say, for example, the zeros, uh, or you can say the zeros beginning in a decimal. That would be much more understandable. Beginning in a decimal are insignificant, and the zeros ending in decimal are insignificant. So both the zeros, if you're ending with a zero and if you're beginning with a zero, they are both insignificant. They are not counted or referred to as significant figures. But zeros in between numbers, zeros in between numbers are considered significant. Like, for example, 2007 is going to have four significant figures, because those two zeros in the middle do hold value. And now what's going to happen is, um, again, it's the same thing with it. And the zeros at the end of any random number may or may not be significant, depends on your use. So, for example, 200 can be written as that it's, one significant figure. But if it depends on the question, you can even write it as three significant figures. It depends on the question itself. Is this fair, guys? So that this is not an issue. This is like something that we already know how to do. All right. So zeros at the end of a number, and this time around, I'm not talking about a decimal. I'm talking about a number. So zeros at the end of a number may or may not be significant. May or may not be significant. Clear? Is there any issues with this? Anyone who does not get this, let me know. This is perfectly, like, completely childish, though. You already know this. Yes. Did anyone have any questions? Nope. All right. Now, what's going to happen next is that, for example, now also one thing that I've noticed is that, in paper two, now this will be very crucial to you guys, because you guys will be one of the first people who actually give their paper twos without the calculator. Exact values are a thing. And what are exact values? We will also learn this in detail when we, go through with trigonometry. But I want you guys to, be aware of these things. Exact values are when you cannot further simplify it. Like, for example, if your question says, and this may happen that your question says that leave your answer as an exact value. What you're going to do then is just simply leave it unsimplified. So you can leave it as, it's a what you may call an exact value answer is you can say a simplified fraction. Obviously, exact values do not mean that you can write 400 over or 100 over 400. This is not exact values. An exact value answer would be 1 over 4 because this can be further simplified. But 1 over 4, if you do not want to further simplify it, and if simplification of it further means use of the calculator and stuff, you can just leave it as it is, and it will be considered an exact value. So a simplified, you can say, fraction is an exact value. Also, the most common form of writing down an answer in its exact value is, writing it in terms of square roots and cube roots and in terms of roots. So, in terms of pi, any answer that you've written in terms of pi, or you can say, or in terms of roots, in terms of surds, is you can say it's referred to as a simplified. It's referred to as writing down your answer in exact values. Then again, there are certain conditions to this as well. If your examiner says that you have to write it in exact values, then you sure you have to write it down. And this will be heavily applicable now in paper two because the calculator is strictly forbidden in paper two as well. Clear? Also, a few hints just so that you guys know what's up. Whenever we're writing angles down, so let me write it down somewhere where it's a bit more visible. So, for example, angles are always rounded off to angles. So, wait, round off. So, if you're rounding off angles, they are always rounded off to 1 dp. And by dp, I mean 1 decimal place. All right. Similarly, if you're talking about money, any sort of money calculation, any sort of anything written in dollars and stuff, that's always written as 2 decimal places. All right. So if it's not mentioned, you can write it as it is, write it up to this point, and this will be considered correct. So money calculations are 2 decimal places, and angle calculations are always 1 decimal places. Anything that anyone does not understand.
Sir,
Perfect.
sir, I have a
Uh,
question in significant figures.
yeah, so
Like for example, if we have the number 6.20,
wait. 6.20. Yes.
is it zero significant?
No. The reason why zero is not significant is because of the fact that 6.2 is going to be considered significant. But having said that, what if it was 620? Now, so my question to you is, do you think that this is significant or no? The zero now.
It could be if they tell us to write it in, I don't know.
Yes, you're absolutely right, Zoya. It depends on the question. Now, for example, if your answer is 619 and they say rounded off to three significant figures. Now, this is already in three significant figures, but they're saying round it off to three significant. So then 620 will be considered significant. But I've written over here, Zoya, that it says in a decimal. So 0 point, I forgot the example you said, like 62 or something, 620. Yes, this 0 and this 0 is not significant. These two are significant. Same goes scenario for 6.02. Now, this is significant, but 6.020, in this, the middle 0 is significant, the last one is not. So this is three significant figures. Clear, sir?
Yes.
All right. Now, exact anyone has any issues? I'm not focusing more on exact values because of the fact that, we'll do it all over again. Like there's a table that you guys need to memorize, and we'll do that in trigonometry. Anyone who does not get this, let me know. Also, a question I have for all of you is, what do you think is the difference between estimation and rounding off? Yes, it's an open-ended question, guys. Anyone can answer. Okay, what do you think the difference is? Let's start off with Basit. Yes, Basit. Basit, are you there? Basit, I know you're here. I think so, Basit was here. Okay, Basit can't hear me. Yes, honey, what do you think is the difference between rounding off and estimation? Hello, honey, can you hear me? Can you guys not hear me? Zoya's asked me question as well. Apologies, Zoya, I just saw it. Yeah, Zoya, no, what do you think will be the difference between a rounding off and estimation? Yeah, Zoya?
Um, I think estimation is normally done like the unit, rounding from a unit.
Okay. And what about rounding off?
It can be, with multiples of tens or hundreds.
Hmm. Very well done, Zoya. Excellent, actually. She's absolutely right. The most major difference between them is the fact that estimation is always done to a rounding off is it's kind of like think about it on terms of a larger scale. Rounding off is always done to the nearest multiple of 10, like nearest 10th term, nearest 100, nearest 200, whatever it is. Estimation, on the other hand, is done on a very small level. And what sort of smaller level it is, that Zoya was absolutely right, to like 1 unit, or technically, whenever we say like if I were to explain like generally what happens is that estimation is done. It's kind of like rounding off to one significant figure. So estimation is rounding off indeed. Again, it is rounding off, but it is rounding off to a certain significant figure. Instead of, rounding it off to multiples of 10 this time around, it's going to be a certain significant figure. Now, what's going to happen is that in some cases, obviously it's different. Estimation is extremely different in all of those cases. Like, for example, if it's 7.8, or wait, let's just say 17.8, and they ask you to estimate it. Now, estimation is solely based on your own perception of what is going to be much more easier for you. So I'm not going to estimate it to like 20. That is too far. I can easily estimate it to 18. All right. And the reason why I can estimate it to 18 is because it's always rounded off to a certain significant figure. It may be mentioned how many significant figures, it may not be mentioned. But if you're going to get it wrong, if you estimate something very big, like for example, 74 can be rounded off to 100, but it is estimated to be 70. Is this clear? Estimation is always done on a smaller scale. You're just trying to get an alternative, easier way. You're trying to estimate an answer. Rounding off is just rounding off. It's different from the estimation. Estimation is just you're trying to get an idea of the number and you're trying to solve it without the use of extensive use of calculators. So these are these are all of these topics that we've covered. They are your what you may call um, paper two oriented questions. Obviously, why not paper four? Because I don't think I think it's a bit foolish to ask someone to estimate 7.4 times 8.2 when they can just simply do it on the calculator. So the examiner isn't dumb. He's not going to make that mistake. He is going to let it be like it's going to give you in paper two, and he's going to say, find out an estimated answer for this or estimate the answer for this. So what I'm going to do, 7.4 times 8.2 can simply be estimated to 7 times 8, which is, roughly, I forgot what it was. I think 56. Yeah. And your original answer is not going to be far behind as well, not that far behind. Clear? Whereas rounding off would have been different. Rounding off in this scenario could have been different, like, 7.4 and 8.2. If you were both rounding it off to the nearest 10, then it would have just been 10 times 10. And the answer would have been 100. Whereas the answer I got from estimation was 56. So estimation, you can clearly see that it gives you a much more closer answer as compared to your rounding off. Anyone who, yes, someone's raised their hand. Yes. Saad. Yes, Saad.
Or should we estimate before calculating the should we estimate before multiplying or after multiplying?
Okay, it depends on the question as well. Like, for example, you should do it before. Like these type of questions, if the same question, if this question is given, oh, I think I remember, I hope I can remember, there was a question a few days ago where you had to estimate something and it was inside a square root. I don't remember. But Saad, very good question. If the question says, if it is said in the question, okay, do not do estimation by yourself. If it is written in the question to round off or to estimate or to give an idea or whatever the keyword may be, if it says, then only do it. And Saad, yes, you have to do it before. Then what is the point of estimating it if you have not done it before? Rounding off is done at the end. The reason, can you tell me why, Saad, we do not do rounding off in the beginning and we do estimation in the
Uh,
beginning? Can anyone?
the difference
Yeah.
in the results will be very big.
Yes. Okay. Let's just say that you have 27 times 27.2 times 28. Wait, these are two big numbers. 7.2 times 8.7. And if I'm estimating it, what will be my estimation? My estimation will be 7 times 9, which is equal to 63. But if I am, what you may call, rounding it off. Now, the reason why I do not do rounding off before is because of the fact that what is it going to do? If I round off to the nearest 10, what is going to happen? It's going to become uh, 10 times 10, which is equal to 100. You can clearly see the difference that it made. But if I'm rounding off to the nearest 10 and first I do this, what will be the answer to 7.2 times 8.7? I don't really know. Can any one of you check? Can anyone tell me the answer of this? Like, use your calculator.
62.64. 64.
62.64. Now, if I round it off to the nearest 10, the answer is 60. So you see how close I got. But if I round it off before, if I made it to the nearest 10, because obviously the standard is going to remain the same. You're either going to round it off to the nearest 10 or some stuff of that sort. Clear? So if I round it off before to the nearest 10, the answer became 100. And now if I round it off afterwards, it became 60. But you need to estimate before. I estimated it before and the answer became 63. If there's anyone who doesn't understand this, let me know. Yes, people?
Sir?
Yes, Zoya?
So, for example, I have a number that's 7.4. If I rounded off, sorry, estimated to like 8, will they mark it wrong?
Yes, it will. Yeah, they will. Because Zoya, why are you rounding it off to rounding it off to 8? You need to round it off to a 7. Guys, one thing that you need to realize is this rule applies to everything. You need to, even if you're okay, the difference in between rounding off and estimation is not of it is of the degree of rounding off and estimation. Like this is on a larger scale and estimation is on a smaller scale, but at the same time how you round something off is going to remain the same. All right, so 7.4 cannot be written as 8. It is going to be, because it's less than 5. 7.5 would have been rounded off to 8, technically estimated it off to 7. Is this clear to them?
Okay, so another question. If I have 7.25 now,
Mhm.
and yeah, so if I estimate it off to 7.3, and
But
another option I have is to estimate it to 7. Which one will be right?
that depends on the question as well. All right. Now, for example, Zoya, your question was 7.25, and they are asking, they will say estimate up to one significant or if it says estimated up to one significant figure, rounded off to a 7. But if they will okay, they will not leave it so blank. The examiner will obviously mention it. All right. If he doesn't, then you have the choice, whatever you want to do. But obviously, the examiner is not that lenient. He is always going to tell you what you have to do. So 7.25 can be rounded off to a 7 if it says 1 SF is significant figure, or 7.3 if it says two significant figure. But Zoya, there is no chance at all in any world that this can be rounded off. He says to estimate it to 8. No, this cannot even be rounded off to 8. All right. He can ask you, like, for example, he can say rounded off to the nearest two decimal places. Then this is the case. Okay, what if he says rounded off to one decimal place? Then you will also write 3, because he's saying the same thing. He's just setting the metric for it. The metric is one decimal place, two decimal place, whatever it is. But he will never, like, I don't think I can imagine 7.25 ever being rounded off. You can say, even if he says rounded off to the nearest whole number, the nearest whole number is still 7. Is this fair, Zoya?
Yes.
So it can never, and also one thing can happen. Yeah, and that have we've already discussed. Like 7.3 can come. That's the only thing that can happen. Clear?
Yes.
Anyone with any other issue? Uh, Anyone who does not understand this, let me know. Okay. All right, guys. I'm afraid we're left with time. Really sorry, Zoya, for making you wait this much today. Hopefully, it won't happen again. Until then, the message is clear and simple. Keep smiling till I see you tomorrow. Allah Hafiz, guys. I'll see you guys tomorrow. Bye bye.
Well,
Allah Hafiz, sir.
Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz. Allah Hafiz.